After witnessing the manufacturing process of fasteners, we now understand why Musk would assert that China is the hub of global manufacturing. The quality is on par with that of Germany. Now let's take a tour of Bytool's factory to see how fasteners are produced. The bundled steel are the raw materials for making fasteners, made of 45 low-carbon alloy steel. They possess excellent tensile strength and yield ratio, making them ideal for crafting high-strength bolts. Before bolt production, the steel is placed in a heat treatment furnace for annealing to reduce residual stress, stabilize dimensions, and minimize the tendency for deformation and cracking. A massive heat treatment furnace can accommodate 5 bundles of steel. Once the furnace is sealed, the CNC system is activated to heat the steel. Digital temperature control allows for precise management of the furnace's temperature and heating duration. After 15 hours of constant heating at 740 degrees, the annealing process is complete. Then workers operate a lifting machine to raise the furnace lid, and an instant orange-red flame engulfs the furnace. The worker's task is to wait for the furnace fire to extinguish. 6 hours later, the steel has cooled to room temperature. Workers use a crane to transfer the 5-ton steel to the next processing workshop for shot peening. The steel is placed on the spiral shaft of the shot peening machine, which then flips the steel into the peening chamber. The double-sided structure of the shot peening equipment significantly increases efficiency. The surface of the steel, after peening, becomes smooth and shiny, exhibiting a titanium metal texture. Next, the steel proceeds to the straightening workshop to correct any curvature. Pass the starting end of the steel through the straightening roller and a carbon powder box, then connected to the winch with a chain. As the winch rotates, it draws the steel through the straightening equipment. Steel with a diameter of 10 mm, once calibrated by the 5-axis rollers, becomes uniformly straight with a consistent specification. When the steel passes through the carbon powder box, it picks up a layer of graphite powder, which serves as a lubricant and rust preventative, facilitating the steel's release from the winch onto the frame. The straightened steel is then transferred to the cold heading workshop. The steel is inserted into the cold heading machine, and as the pulley moves forward, it is immediately made into many bolt blanks by the compression mold on the cold heading machine. Cold heading is a process that utilizes the plastic deformation of metal under external force and redistributes and shapes the metal structure using molds to form the required parts or blanks, ideal for producing standard fasteners such as bolts, screws, nuts, rivets, and studs. This multi-station automatic cold heading machine, designed and manufactured in China, has reached an advanced global standard with a daily output capacity of up to 100 tons. Next, we move to the thread rolling workshop to create the threads on a screw. Workers pour a basket of bolt blanks into the hopper of the thread rolling machine. The blanks progress up a reciprocating mechanical staircase, aligning perfectly into the transmission slot at the top, thus adjusting their orientation. Then it enters the thread rolling machine. High-speed reciprocating thread rolling molds can roll a bolt thread in just 1 second. In addition to semi-threaded bolts, there are fully threaded ones as well. Any thread type can be achieved by simply changing the thread rolling mold. The final step is in the heat treatment workshop, where a heat treatment and blackening integrated device completes the final processing. Bolts travel along a conveyor belt into a heat treatment furnace, where they are baked at 400 degrees for 60 minutes to remove surface oil and strengthen the internal metal particle structure. After passing through the 20-meter-long heat treatment furnace, the bolts are immediately submerged in a blackening solution. The acidic solution creates an oxide film on the bolt surface, isolating it from air and preventing rust and corrosion while enhancing wear resistance. Finally, the finished bolts are coated with maintenance oil, marking the end of the manufacturing process. The final step includes spot checks and tests for tensile and compressive strength on the finished bolts.